Hi, everyone. Is this thing on? Can you hear me?
Yeah.
Okay, good. Great. Well, thanks for having us. This is so exciting to see how full this room is. I knew there were a bunch of people registered, but I didn't know there were quite so many. So this is just, extremely exciting to see so many people who are, I think not just wanting to learn about cloud native storage, but actually learning about it because you're doing it. And how do we make it better? And so that's inspiring to me as someone who works at a company that builds a lot of this technology. I think following up on Janny's talk, I wanted to introduce what I see as some of the essential elements of a Kubernetes storage platform. Janny walked us through the history of that. And so the question becomes, what does it mean to be container native? What does it mean to have a storage platform for Kubernetes in terms of capabilities, in terms of types of applications that can run there? And so I want to do that, and then I'm actually going to bring a customer up to give you their perspective, because I think that part of the talk is going to be much more valuable than my part. But I want to set some context. Really just it's a model for thinking about these things. And each application is different, business requirements in different enterprises are different. I'm not going to tell you which solution to pick, but I do want to provide a model for evaluating how you can think about merging business requirements with technology in a way that allows you to succeed. So the context for, I think, really this 12,000 person conference is that there are some really challenging pressures that are exerting themselves on enterprises all at the same time today. So the first is, we have to move faster. I mean, the fast eat the slow. It's for many organizations, it's an existential question. If we don't innovate faster, if we don't bring applications to market faster, then we'll just cease to exist as a company. We'll drop out of the Dow Jones Industrial Average. I mean, the implications of this, I think, are well documented. Pick up any issue of The Economist, Wall Street Journal, whatever. You're gonna hear stories about this. At the same time, there's a potentially way out from a competitiveness perspective, which is that there's a massive data explosion driven by a lot of different trends, which we don't have time to get into. Suffice it to say, companies that can best collect and catalog and analyze increasing large data sets are going to be the ones that are more competitive in their own industry. It doesn't matter what that is. It could be manufacturing, it can be healthcare, it can be automotive industry, as we'll hear about from Ford. At the same time, there is an increasing kind of ever-present security threat. And in fact, in some ways, up top, speed and increasing data are things that can increase risk of an organization. On the bottom is something that takes advantage of increased risk. So from a CIO perspective, they're being told, move faster, innovate more, get more out of our data, and at the same time, don't get us on the cover of the Wall Street Journal as the next security breach. So how do we kind of work out this Rubik's Cube, if you will? Well, the community, all of you have said, containers and Kubernetes are how we do that. By leveraging automation, we can bring applications to market faster. We can actually have more secure applications because computers don't tend to do things like reuse the same password twice, and making a trivial security example, but we can build policies that are always implemented correctly via computers, which is harder to do with people, so we can build more secure applications. And at the same time, we can, because we have automation, because we have computers that can do more than people, we can manage larger and larger data sets, do ML, AI workloads, all running on Kubernetes to take advantage of these increasingly large data sets. That means a new stack has emerged, right? Everybody here is familiar with this stack in some shape or another. It's built around Kubernetes, but it's a pluggable model. So Janik Hiram just talked about a lot of storage plugins based on CSI, but we have interfaces for networking. We have interfaces for security and monitoring. And this stack is built from day one to run across multiple environments. Now, my own experience working with customers is that when they adopt patterns built around Kubernetes, they get a lot of advantages across their business, and you wouldn't be here if you didn't believe in some of those advantages, and so I'm not going to catalog them for you. The challenge I want to highlight is the challenge of bringing the incremental application onto the Kubernetes platform so that it too can reap those benefits. my experience working with customers is that a lot of times it's not technical challenges that prevent apps from running on Kubernetes, it's business requirements. And that could be, we might have an application that can be containerized, can be run as a distributed system, but we've got some sensitive user data, and we're not comfortable putting that type of workload on Kubernetes yet. Or I might have an application that has some strict performance requirements, the kind of thing where if it's down, I can count how many dollars I'm losing per minute. Or I might have backup and recovery or disaster recovery or some type of compliance use case that prevents me from moving that application over to Kubernetes. And as a result of that, whereas we could think about, I'll use an example, which is that most analysts say that 80% or 90% of the enterprise data center is virtualized today. Okay, that wasn't always the case. When VMware started out as kind of the leading provider in that movement of virtualization, it was a point solution for test dev workflows or VDI. You couldn't run arbitrary applications on VMware well, because of the lack of support for those business requirements. But eventually you could, and now pretty much any application, no matter how important, no matter how sensitive, can run in a virtualized environment. We believe that the Kubernetes storage platform is essential for making it so that any application can run on Kubernetes. And using any, I know there's always a risk in doing that. I'm not talking about your ERP service. I'm not talking about your Exchange server. I don't believe those things are going to come over and be run on Kubernetes. But arbitrary enterprise applications, 20, 30, 40, 50% of enterprise apps should be able to run on Kubernetes if we implement a Kubernetes storage platform. The reason is threefold. One, all enterprise apps have data. We can talk about stateless components, absolutely, but we can't talk about stateless applications. Applications have data. Second, existing storage technologies can't keep up with the scale and dynamism of Kubernetes, right? There's a new stack has emerged, which means that some of the tools that we used to use before and we still use today for certain classes of workloads are no longer appropriate for new types of applications. And while there's a desire to minimize the complexity, let's separate out the problem, let's run stateful applications outside of our Kubernetes environment and use Kubernetes for stateless applications or use managed data services. Those solutions have their own problems. They increase complexity because we're managing different platforms. They increase cost. They increase cloud vendor lock-in. We believe that a Kubernetes storage platform not only helps you successfully run stateful applications on Kubernetes, kind of that's obvious, but also that it's the key solution to being able to run, again, 50% of your enterprise portfolio on Kubernetes. So from a CIO perspective, we can get agility for kind overall because a majority of enterprise applications can run on Kubernetes. Now, I'll just kind of give a caveat at this point, which is I'm a big fan of CSI. As Lisa mentioned, we have people that are core members of the CSI community, and things are so much better from an end user perspective now than they were prior to CSI. But don't assume that because a solution has a CSI plugin, that it's Kubernetes native. I'm not saying that it's not appropriate for your workload. Only you can judge that. But I'm going to argue that a Kubernetes native storage platform is different from a storage platform that simply speaks CSI. And I couldn't help but say, throw seamless integration under the bus. What exactly does that mean? I don't know. Could someone have said this is a seamless integration into your car audio system? Probably, but I think we can see that some seams are more seamless than others. If I had to summarize in a single slide, what is a Kubernetes storage platform? It would be based around this idea that there has been a fundamental change in how we run our data centers. And when I say our data centers, I mean on-prem or in the cloud, right? Our infrastructure would probably be a better word. Prior to Kubernetes, it was a machine-defined control plane. The most important thing in our data center was the EC2 instance, or it was the VM. And all of our management tooling was around managing those machines. And that got us pretty far. It got us to where we are today. But Kubernetes realized, or I should say the people who built Kubernetes, the community, all of you realized that really, if we have agile infrastructure, that's a necessary component of having an agile enterprise, but it's not sufficient. What we need is agile applications. So let's flip the model. Let's focus on applications. Let's, in deploying and managing our applications, have the application control plane also control the infrastructure. And so that is a lot of the projects that Janet Kiram talked about that you're going to be learning about today is a way for Kubernetes to actually manage the entire data center, including the underlying infrastructure. But the important point is we need to be able to control the infrastructure at an application level, not at an infrastructure level. Now, that creates a bunch of problems for storage because storage historically has been all about machine-based capabilities and infrastructure-based capabilities that kind of blissfully ignored what was happening at the application level. That was seen as a constraint that you would do well to avoid because it introduces a lot of messiness that by focusing only on the infrastructure, we can kind of just ignore. But that doesn't work in a Kubernetes model. So, there are lots of different ways to slice and dice this. This is one view of what I see as the 5 essential elements of a Kubernetes storage platform. And I've got a slide on each of these things, so I'll just give a quick introduction. So one is it needs to scale to the level that Kubernetes scales to. It seems like a platitude. In fact, all of these seem like a platitude until you're running in production, and you realize that systems that were designed for relatively small number of volumes or relatively small number of storage operations per minute don't scale when you put it behind Kubernetes, and Kubernetes starts changing a bunch of stuff beneath you, and you have no idea why it's doing it, except that you defined a YAML file that told it to. And so Kubernetes is going to go do it regardless of what's running underneath the scenes. And it can make it so when you do functional testing to say, some of the operations that Janet Kiram talked about in terms of provisioning a volume, attaching a volume, maybe you simulate a node failure to see if Kubernetes can reschedule your pod, all of that functional test works. And you say, okay, great, then you push to production and you multiply all of those operations by 1,000 and you realize that the system is not as robust as you thought it was. That's what I mean by Kubernetes scale. The second piece is Kubernetes nativity or nativeness. The idea that Kubernetes gives us new primitives for managing applications, things like a namespace, and all of our storage and data management functionality, our backups, our disaster recovery, our security, should be usable at each of those Kubernetes primitives level. Meaning if I want to back up some applications, well, I can back up a namespace. I don't want to back up individual pods and individual volumes. I want to be able to say, back up namespace 1 and have it happen. That's challenging with machine-based storage systems. The third is an application focus, and this is a little bit of a rehash. But what I mean by this is that, it used to be that most applications ran on a single machine. That's why we needed virtualization, because we were sick of running a single application on an entire server. Let's virtualize it. Let's get 10 applications per server now, be much more efficient. With Kubernetes, with distributed applications, with microservices, a typical new application is going to run across multiple machines. It's composed of multiple containers. And again, that means that we can't use machine-based snapshots in order to manage those apps. Finally, I've been looking for a good metaphor to explain what I mean by a complete Kubernetes native stack. The way I see it is there's like in a physical system, sometimes there's a minimum energy needed in order to activate some reaction or some system. With enterprise applications, it's kind of the same way. There are enterprise apps that they need a backup plan in place because, well, someone said we need a backup plan. We need to keep this data for 7 years. Well, it needs to be encrypted. It needs to be able to run in multiple environments. There's kind of a minimum set of requirements that a Kubernetes storage platform needs to provide in order to have it support an arbitrary enterprise application. This is one of the things that we see our platform teams that we work with struggling with, is that there's always some user in their organization who has this requirement or that requirement, and it's kind of you end up eliminating possible apps that can run in your platform unless you have a breadth of a solution. And finally, it needs to work in a multi-cloud world. So I want to make sure that I can have time to invite Jason from Ford Motor Company to give his perspective on this. So I'm going to go through this a little bit quick. This is a chart that you'll notice doesn't have a y-axis because I didn't want to get into a debate of particular environments and what the cloud versus on-prem environment looks like. But working with some analysts from Gartner and Forrester and IDC, I've been realizing that from their perspective, they see an order of magnitude change in a typical VM-based environment and a Kubernetes environment on 2 metrics. One is the number of storage operations per hour that a system needs to be able to support, and the second is the number of volumes that a system needs to be able to support. We have another customer, Harvard University, that I'll be speaking on Wednesday at 5:30. They're running thousands of pods per EC2 instance. That's an order of magnitude higher than a typical Amazon environment. That's a really dense system, and they're doing that because they have the automation from Kubernetes that allows them to do that. That's really a game changer in terms of the requirements that an underlying storage system needs to be able to perform. Container granularity is simply the idea that machine-based snapshots and machine-based backups are no longer going to work. So for instance, if I want to back up my 3-node Cassandra database, it's a distributed system. How do I do that? Well, I can't take machine-based snapshots because then I have a bunch of MySQL data that I'm going to need to get rid of before I can recover. I also can't just take serial snapshots of a distributed system because then I'm going to get data corruption. I need to be able to operate at a container granular level, just backing up my Cassandra data, but I also need to do it in a way that is application consistent. Oops, sorry. Namespace awareness, I think I did a good job of covering this earlier. It's basically the idea that all of my storage capabilities need to be executed not only at an individual pod level, potentially at an application level, an arbitrary tag within Kubernetes, or at the entire namespace level. If I have thousands of pods, I can't do pod level operations for everything. I need to be able to use the Kubernetes primitives that allow me to manage, say, those 1,000 pods. Janet Kiram mentioned this earlier. It's really important when we take an application focus that we focus not just on data. I mean, this is Cloud Native Storage Day. I really like storage, but it's not all about data. It's also about applications, which means we need to think about our application configuration, our Kubernetes objects, making sure that when we're doing something like a backup, those objects come along with the data so that we can facilitate recovery. We need to be able to do all of this in a multi-cloud world. Once you've done all that, you have a Kubernetes storage platform, which means from the business requirement perspective, DR is taken care of, running any stateful app is taken care of, multi-cloud migrations, backup and recovery, compliance, governance, security, capacity management. All of these business requirements, which is what VMware had to solve in order for arbitrary enterprise applications to run in virtualization, are also solved for Kubernetes. The one slide I'll include about Portworx before I invite Jason up is that we do all this. We're here all week. We can show you demos of backup and DR and security and all that type of stuff. Suffice it to say, we love working with customers that are trying to get the most out of Kubernetes. We'd love to help you, but I think what I want to do now is invite Jason Presnell up from Ford Motor Company just to give his perspective. Because I think I've laid out a structure, but what do they say? The best plans are nothing in the face of reality. So I wanted to invite reality up and just ask a couple of questions to Jason, and I think we go a lot of different directions. But one of the most interesting things we were talking about last night is I kind of presented a model where we start with stateless applications and then we add stateful applications to Kubernetes. And Ford Motor Company actually did it the other way, which is to say that your Kubernetes journey started with stateful applications. So could you talk a little bit about that?
Yeah, sure, no problem. So hello, everyone. Good morning. Good to be here. Thank you for having me up here. So yeah, as was alluded here, that we started the journey on a Cloud Foundry journey many years ago. We're on roughly year 5 now of that transformation. So a lot of our internal structures were built around moving towards a Cloud Foundry type of structure. And then we started to get to a point where, well, what's next? What's the next way to go? Most particularly in data services components. Cloud Foundry does have those, obviously, but we felt that there was a better opportunity to find a way to better automate our stateful type applications, databases, caching, so on and so forth, messaging. We're like a classic enterprise. We got it all, right? So as part of the cloud native transformation for our applications, we looked towards Kubernetes a few years ago to say, okay, here is the platform we're going to take for our stateful applications first. So we actually still take our stateless towards Cloud Foundry first, and then stateful towards Kubernetes, and we've been doing that for the last 2 years now.
Great. And one of the things you said yesterday, which I thought was, I hadn't heard it before. I mean, I believe it, and it's kind of, it underlines the presentation. When I hear it from someone who's actually having to do it, it's different, which is to say, your view is that it's easier to run a stateful application on Kubernetes than it is outside of Kubernetes. And you talked about operators and why kind of CRDs and operators facilitate that. Could you talk a little bit about your vision for, like, why is it not just, why is it easier to run on Kubernetes when you have that automation?
Well, you have the whole life cycle of the application, right? So the operator provides a way really to enhance our ability to deploy that application. We can take that operator from a vendor and carve it out for each of the individual customers overall. But all of that automation is built into the CRD. It's built into the operators. So instead of us having to string it together by hand or putting our own automation around that, the operator abstracts all that away from us. We just put in the numbers and hit go, and another one is up for the customers. So in the end, it really speeds up our ability to deliver to the customers a consistent and automated way to provide that service. But as more operators come in, we're able to deploy those faster for the customers. It's all a matter of time and automation. We want to be able to turn around in minutes to the customer and having a consistent deployment strategy overall. The maturity of Kubernetes in terms of the adoption can vary for customers. So some have the expertise, some do not. Whereas an operator can give you that level of, I would say, consistency across the platform.
Okay, great. And so the last question would be, so you're building a platform that potentially any enterprise application can run on. How do you think about kind of providing what I call those business requirements to users? Because you don't always know what's running on the platform, and you don't know the level of expertise that each individual app team has when they're building that application. So how do you kind of guarantee or attempt to guarantee some level of performance and security and kind of generic enterprise requirements when you're not the one who's actually running the application?
Yeah, so as I said, maturity definitely is variable within any type of adoption, especially with Kubernetes. Some people don't even know how to spell Kubernetes, let alone run something on it. So being able to provide that consistent approach for that customer is really key. But overall, I would say that having education, having a dev enablement strategy, because when you go to Google and you look up something, 6 months later it might be out of date, right? We're moving that fast. So being able to provide a consistent platform is all around the education for the users. Having interviews with those customers, understanding what their needs are and things like that, and being able to package those in a way for the applications and the delivery for the enterprise as a whole.
Okay.
We're getting the music.
Great. Well, the shepherd's crook is pulling us off stage. Yep. Thank you, everyone. Jason, hopefully, will be able to stick around in case that breaks and things like that if you have any questions
Indeed.
for them.
Yep.
And thanks again.